All right, so now we can talk about trig functions of any angle. We've talked about right angle trigonometry now. So now we want to be able to extend that to any angle. Doesn't matter what it is. So we need to be able to think about this in a slightly different way. So if we let theta be any angle in standard position and let our point P be xy, be a point on the terminal side of theta, and if we define r equal to the square root of x squared plus y squared as the distance from 0, 0 to xy, as shown in our figure here, then the six trigonometric functions of theta are defined by the following ratios. So the sine of theta is equal to x over r. Oops, sorry, sine of theta is equal to y over r. And cosine of theta is equal to x over r. Tangent of theta is y over x, where x is not equal to 0. The second column is just the reciprocals of the first column. So cosecant of theta is equal to r over y, where y is not equal to 0. Secant of theta is equal to r over x, where x is not equal to 0. And cotangent of theta is equal to x over y, as long as y is not equal to 0. So if we have these, no matter what we're given, in other words here, we can always find our six trig functions. So if we have these, this allows us to be able to see different things for any angle out here. So let's look to see what we mean. So the first thing that we have is our unit circle. The faster that you learn this unit circle, the easier it's going to be. One thing to help what I do in my on-campus class is I give them a blank one of these and I give them a few minutes and I want them to fill it out without a calculator. That way, if you get used to seeing what 30 degrees, 45, 60 in a sense here is, we can convert those to radians for the pi over 6, pi over 4, pi over 3. We know our cosine comma sine for root 3 over 2 comma 1/2, root 2 over 2, root 2 over 2, and 1/2 comma root 3 over 2. We can take this and we can extend this to any angle inside of our unit circle. So it helps you get to know and do this. So whether you're taking this class online with me or on campus, if you're doing this is what you need to make sure. And this is why I do it, because it starts getting you thinking in this mode. So the point below is on the terminal side of an angle theta. Find the exact value of the six trig functions. Anytime we're given this, let's draw it out. So -6, +8. So we have this. We have this right here. So if this is my angle theta, so I had -6, and I have 8. First thing we need to do is we need to find r. R is equal to the square root of x squared plus y squared. So that's 36 plus 64. Square root of 100 is 10. So we found our r. So now we need to find all six of our trig functions here. So we have our sine, cosine, and tangent. We've got cosecant, secant, and cotangent. So for the sine of theta, by our previous thing, I said it was y over r, because that's opposite over hypotenuse. So that's equal to 8 over 10, or we could reduce that to 4 over 5 if we wanted to. Cosine is -6 over 10, which is -3 over 5. Our tangent is going to be opposite over adjacent, so that's going to be -8 over 6, which is -4 over 3. Cosecant is just 1 over sine, so that's just going to be 5 over 4. Secant is 1 over cosine, so that's just going to be minus 5 over 3. And cotangent is just 1 over tangent, so it's going to be minus 3 over 4. So once we find basically these three, we flip to find these three. So we're given some of these. These are already answered for us here. So tangent of 3 pi over 2. So tangent is sine over cosine. So that's my y over x. But in this case, that's going to give me negative 1 over 0, which gives us undefined. Sine of 210. So 210 is in the third quadrant. So since it's in the third quadrant, a y value means that it's negative. In other words, 210 puts me here. So that's the same as sine of 30, which is going to be 1/2. Well, since we're in the third quadrant, my y is negative, so therefore we get negative 1/2. I'm using some theory of reference angles here, which we'll talk about later on how we can really learn first quadrant stuff, and then we can transform it to each of our other three quadrants. So cosecant of 7 pi over 4 is the same as 1 over sine of 7 pi over 4. 7 pi over 4 is actually over here. So 7 pi over 4 puts us down in the fourth quadrant. So therefore, that means in the fourth quadrant, we have that our y value is negative. So therefore, what we really have here is 1 over negative root 2 over 2, which is negative 2 over root 2, which becomes just simply negative 2 root 2 over 2, which is negative root 2. Cotangent of negative pi over 2. Well, cotangent of negative pi over 2 is the same thing as 1 over tangent of negative pi over 2, which is the same thing as 1 over the tangent of 3 pi over 2. But we know that the tangent of 3 pi over 2 was undefined because we had negative 1 over 0. So this is 1 over negative 1 over 0, which is actually 0 over negative 1, which is 0. So we're still looking at this in different ways, but we're still using our entire unit circle here. So if we learn this, it makes it so much easier because then we can see exactly where everything is at. So one thing to note for all of our trig functions, they're just like our x's and y's from our old school ordered pairs, that in this case, so this is what our x's and y's look like for plus and plus, minus plus, minus minus, plus minus. So another way of looking at this would be in terms of sines and cosines. So in quadrant 1, everything is positive. Don't care what it is, it's all positive. For quadrant 2, since sine and cosecant, since sine is positive, sine goes with cosecant, so cosecant is positive. Everything else is negative. For quadrant 3, the only two positives are tangent and cotangent. Because of this fact, we know that our sine and cosine are both negative, which means secant and cosecant are both negative. In quadrant 4, cosine and secant, because they go together, are positive. Everything else is negative. So we just have to be aware of where we're at and kind of gives us an idea of everything. So if we look at this one's going to kind of give us some conditions. So here is our conditions we have to know exactly what we're looking at. So in this case, we're told that sine is positive. Okay. So sine is my y values. So we're positive and positive for sine. Secant is really the same as 1 over cosine is less than 0. So we're looking for where is cosine less than 0. So cosine's negative and cosine is negative. We're looking to see where do they overlap. They overlap in this quadrant, which is why quadrant 2 is our solution here. We can do the same thing here. So I'm going to start with the sine because I already had a sine in the previous one. Sine is less than 0. So therefore, sine is negative. Sine is negative. So all I'm doing, I'm just identifying which quadrant could it possibly be for each condition. So tangent is greater than 0. So tangent is positive. Tangent is positive. So they overlap here, which is quadrant 3. So it's just a matter of figuring out where each individual statement is true, and then seeing where they overlap. So we're told find the exact value of each of the remaining trig functions of theta, given that cosine of theta is equal to negative 5 over 13, and we're in quadrant 3. So we have to use both of these to identify this. So if we were really thinking about this, think about if we drew this right here. So we need to find sine, tangent, cosecant, secant, and cotangent. So here is my theta. So sine of theta is going to be negative 12 over 13. Tangent is going to be negative 12 over negative 5, which is 12 over 5. Cosecant is 1 over sine, so negative 13 over 12. Secant is 1 over cosine, which is negative 13 over 5. Cotangent is 1 over tangent, which is just going to be 5 over 12. So it's all a matter of first identifying where this statement is true at first, and then we can work from there. So we need to identify where cosine of theta is less than 0 and tangent is negative. So if we were to draw this out, it would look just like this right here. So we need sine, cosine, cosecant, secant, and cotangent. So sine of, and this is our theta. So sine of theta is equal to 12 over 13. Cosine is negative 5 over 13. Cosecant is 1 over sine, so that's 13 over 12. Secant is 1 over cosine, that's negative 13 over 5. Cotangent is 1 over tangent, so that's going to be negative 5 over 12. So we just have to make sure that we're identifying each piece first and then breaking it down. So I talked about this earlier a little bit on how I was using reference angles. So if we let theta be a non-acute angle in standard position that lies in a quadrant, its reference angle is the positive acute angle theta prime formed by the terminal side of theta and the x-axis. So basically what we're saying, given any angle that's not on one of our poles, so not on pi over 2 pi, 3 pi over 2, or 0 or 2 pi, we also need our angle not to be in the first quadrant because all of our reference angles are between 0 and 90 degrees. So we have 3 cases of that because we got 3 other quadrants. So if we are in quadrant 2, so our angle is in quadrant 2, then theta prime is going to be equal to 180 degrees minus theta. And that's going to give us this small angle here, which will actually reference to an angle back over here. Now, if theta is in the third quadrant, we're going to take our angle theta and we're going to subtract 180 degrees. And pretty much it's going to give us this angle right here. Now, our last case that we could have here, in other words, because the last one was in quadrant 3. Last one is if we have an angle in quadrant 4. We're going to take 360 degrees minus this theta prime, and that's going to give us a new theta prime that's in the first quadrant here. So in all cases, we're looking for something that's going to give us an angle that is up here in quadrant 1 is what we're looking for in all cases. Because once we have those, we can take our normal angles that we know, 30, 45, and 60, find sine, cosine, whatever we need. And then we look to see where was the original angle at to determine positive or negative. So let's look at an example of that. So first, we're just wanting to find our reference angles. So negative 150 degrees. So negative 150 degrees puts us here. I need my first positive. So first thing I need to do, I need to add 360 degrees. So then I'm actually looking at this angle. We first need a positive angle. So we add 360 degrees and we get 210 degrees. Now, referencing back up here, our angle is between 180 and 270. So we're going to take our angle, we're going to subtract 180. So therefore, we actually get this angle right here. That's just a 30-degree angle. All right, in terms of radian measure, it's a little bit more complicated in looking at it, but 13 pi over 6. Notice that the 13 is greater than 2 times that. So, excuse me. So this 6 times 2 is 12. Notice that my numerator is greater than 12. So what that means is that I have made one full revolution plus some. So my angle is actually this angle right here. So since that's greater than 12, 13 pi over 6 minus 12 pi over 6 gives me pi over 6. It's my first positive angle. It's between 0 and 90. So therefore, it is my reference angle here. Finding reference angle is just the first step because in this next case, we want to use the reference angle to find the exact value here. So tangent of negative 750 degrees. So the first thing we have to do is we have to add multiples of 360 degrees until we make it to the first positive iteration. So what we did is we took 360 times 3 to get 1080 because you have 360, 720, 720 still less than negative 750, and then you got 1080. So that's the 3 multiple. So we get 330 degrees. That puts us here. So we take 360 minus 330 to get 30. We then figure out the tangent of 30 degrees, which is root 3 over 3. So that puts us here. I'll use theta prime as that. Now, our original angle was negative 750 degrees. So negative 750 looks like this right here. Negative 360, negative 720, negative 1080. Oh, sorry, hold on a second. Why don't I redo that? Negative 360, negative 720, negative 750. So we're actually in the fourth quadrant on our negative 750. So since we're in the fourth quadrant, tangent is negative here because they're opposite signs for sine and cosine. So negative 750 is the same as negative tangent of 30, which is negative root 3 over 3 as our answer here. So for negative 47 pi over 4, we're looking at multiples of 8 pi over 4. So we need to see how many multiples of 8 pi over 4 do I need to multiply by before I make it to a number that's greater than 47. So that's going to be times 6 because that gives me the 48 pi over 4. So when we add that, we get pi over 4. So really we're looking at cosecant of pi over 4, which is 1 over sine of pi over 4, which is still root 2. And if we were to draw this out, so negative 8 pi over 4, 16, 24, 32, 40, 47. So we're actually in the first quadrant. Since we're in the first quadrant, we followed the sine of pi over 4, which gives us root 2 as our answer here. So some study aids here that might be helpful to you to help you learn and understand stuff. So we have a 30, 60, 90 triangle and a 45, 45, 90 triangle. These are very helpful depending on what we're given. 30 degrees and 60 degrees follow this one down here. My 45 follows this one up here. So sine of 30 degrees or sine of pi over 6 is 1/2. Cosine of 30 is root 3 over 2. Tangent of 30 is root 3 over 3. Sine of 45 is root 2 over 2. Cosine of 45 is root 2 over 2. And tangent of 45 is 1. Notice that for 30 versus 60, that sine of 60 is equal to cosine of 30. We used our co-functions. So sine of 60 is root 3 over 2, cosine of 60 is 1/2, and tangent of 60 is root 3. If you learn this table, this will help you learn the unit circle, or if you learn the unit circle, you don't have to worry about learning this table. We can also use stuff at our poles. So we've got our 0, 90, 180, 270, and 360, which is the same thing as 0, pi over 2, pi, 3 pi over 2, and 2 pi. So sine of 0 is 0, cosine of 0 is 1, tangent of 0 is 0. Sine of 90 is 1, cosine 90 of 0, tangent of 90 is undefined. Sine of 180 is 0, cosine 180 is -1, tangent of 180 is 0. Sine of 270 is -1, cosine of 270 is 0, tangent of 270 is undefined. And we'll talk more and more about these later on to show you different ways that we can identify them.